Well, this is the numeric case, and that's where you've got the type of expression 1 and the type of expression 2 occurring somewhere or other on this diagram. And these are all numerics, of course, and what we've got is all the primitives in green, and the wrapper classes in what is supposed to be orange, but well, I'll leave that to you to decide. But what you can see is these orange arrows are boxing, and the green arrows represent widening. And the question is, what's the type of the result of this expression? And it's very simple. All you have to do is follow the arrows. And the first common type you come to, well, that's the type of the result. That's pretty simple. So we've got something like short and char. You just follow the arrows each case, and the first common one you come to is int, and that's the type of the result. So it's pretty simple. Now there's one little extra thing to remember. There's a little exception to this rule here, and that is if you've got a literal constant int, right? Now in that case it can be implicitly narrowed to short if the other expression is short or its wrapper class, and it can be implicitly narrowed to byte if the other expression is byte or its wrapper class, and it can be implicitly narrowed to char if the other expression is char or its wrapper class. Right? And it's implicit narrowing, of course, so it won't be done unless it fits. So it'll have to fit the appropriate type. So if you're going to narrow it to byte, it's better fit in a byte, because if it doesn't fit, it won't be narrowed and it will stay as an int. Now, what's more, something like this, which is 12L, so that starts out there, right? It's cast to byte, and then it's cast to char, and then it's cast to int. That is a constant literal int, because it ends up at int. However, something like a 0 cast to a short is a short. It is not an int, because it's ended up at short. Right, so it's only ints that can be implicitly narrowed. Okay, so let's see a few examples. Here's expression 1, and that's the type of it. Expression 2, type of expression 2, and there's a resultant type. Split this up into sets of 3 columns. It doesn't all fit, of course, so I've had to wrap it a bit. So we got double and byte. Let's look at that. Double there and byte there. If you follow the lines, it goes up to double up there, and that's the result. Character and short, I follow that lot, it goes to int, so int is the common type. Char and short, pretty similar, follow that, it's int again. Byte and char, starts down there, and that's again an int. Short and short, those two wrapper classes, they don't have to go anywhere, they are common already, so it's short, which is good because that agrees with what we had before, where the two types are the same. The result is that type. Integer and int, go to int. Char and 64, right, char there. Right, 64 can be implicitly narrowed to char, so it's basically char and char we've got, and the result is char. Short and byte, if you follow those, the common type is short, and that's the result. Byte and minus 127. Minus 127 fits in a byte, so it can be implicitly narrowed to byte, and you've got byte and byte, so the answer is byte. Byte and 512, the answer is int, because 512 doesn't fit in a byte, so it stays an int. It doesn't, for example, get halfway and stay at short. It stays as an int, and therefore it's going to be widened up to there, and you've got the resultant type of int. 0 and 0, that is an int, because 0's by default an int, and so it goes and has a look at the other type, and the other type's int, so it's not a byte, short or char or anything like that, so it can't be narrowed at all, so it's int. It's basically int and int. Character and 512. 512 can be narrowed to char, so It's going to be char. Char in -1 is an int because you have -1 here. You can't narrow -1 to implicitly narrow it to char, so it stays as an int, and therefore the answer is int. Byte and character is going to be int, and that's roughly how it's done. You can fill in the rest. It's all pretty straightforward.